So for the first one, you have to take the derivative of the equation they give you to get the velocity and the acceleration, which I did here on the left. And then you set the acceleration equal to 0, and you get the time. And then once you get the time, you plug it into both equations to get what the velocity and acceleration at that time. For the second one, you have to find the acceleration, so you use the equation that you have most of the givens for, or all of the givens for, to find the acceleration. So you use that acceleration to find the velocity, and then use the velocity to find the time. For this next one, you have to find the velocity given what you're given in the problem. And then for 4, you have to take the integral to be able to find the position, and then you can use what you're given to find the equation for the acceleration and the time. For this next one, you have to take the integral of the acceleration equation to be able to find the velocity. So that one's straightforward. For this next one, you have to find the acceleration of b, the components of the acceleration of a and b, from the acceleration one where that's not based on time. Then this next one, you have to find the velocity and the acceleration and the time to be able to get the times at the different positions. For this next one, you use r, what you're given, to get the velocity and the acceleration, and then you find the magnitude of the velocity and the acceleration. For this next one, you have to use the velocity components to find the position, to find the time for both x and y. For this one, you use to find the velocity, the position, and the velocity in the x and the y, and the position in the x and the y, to be able to find what you're needed. For this one, you need use the normal component of acceleration to calculate velocity, and then plug in get the given values to get the velocity. Then for this one, you use the centrifugal acceleration component, solve for r, and then plug in the givens. Pretty straightforward. And then for this one, you're given components for position and angle. You have to find the velocity components, the acceleration components, to be able to find r dot, theta dot, r double dot, theta double dot. For this last one, I split up into block A, B, and C. You find the acceleration of B, then you can find the acceleration of A from this equation that I have above. And then you can use what you find from A to find. You can get the the block C and the block A part, and then you can use what you find to get the change in position.